Okay, test. Gonna wait a second for Twitch to catch up as usual. Okay, looks like I'm live. Welcome back, everyone. It's been a long break. It's been, I think, a bit over a month since last stream. Some of it was planned. I took some vacation in August. Some of it was not. I took more time off than anticipated, partly because of health reasons after coming back from vacation. In the spirit of transparency, I have to also admit that while most of my time off post-vacation was health reasons, there's definitely one or two streams I could have done, but I didn't because, well, Silk Song came out and it was hard to put the controller down. But that is behind me, and I'm happy to restart the streams for the foreseeable future. So last time, before going on vacation, the last thing we finished was the analysis phase, which is something we spent months on, which was a lot of work, which is basically, okay, we've passed some source code, and we are going to have to do type checking, name resolving, all of this stuff to make sure that, like, not only the code is correct, but also translate it into something that captures that information so that we can then move on to lowering into IR. We have not started the lowering into IR, but the last stream before I went on vacation, we finished the analysis phase. At least for the features of the language that are currently supported. But at least we finished like a large chunk of it. Since I'm just restarting after a month without working on the project, I'm not going to start tackling the lowering into IR just yet this evening. This is something I will probably start next week. What I want to do, however, this evening is to start working on tests, because as we were developing the entire analysis phase, all of our tests were manual tests. Here's a file, let's try to compile it, let's see if it works as expected. But that is not very reliable, and I am sure there are a lot of issues we have missed due to the lack of proper testing. So this week, getting back into the project will be about documentation and testing. And next week, hopefully, unless that project ends up taking more time, next week with a cleaner base, we can start the lowering into IR, the next phase of the project. So yeah, let's get back into it. So, what I want to do here is twofold. There's another phase we've added as part of the work towards the analysis. We've added a new stage. We've added the simplification stage, which is a much, much simpler phase, which is basically, are there things we can simplify at compile time? For instance, if I look at this, if we end up having something which is an addition plus 0, we remove that plus 0, basically. We've type check it, but then we can just, remove that unnecessary operation. Likewise, dividing by 1 is a no-op, we can remove it. We have this simplification phase. We do not have tests for it. So this is something we should start with, I think, because this is a somewhat simple phase that is like fairly easy to test in isolation. And then what I want to start this evening will be, if I go back to this file, I don't have it open anymore. This file right there, this file has been basically my test file for the entirety of the development of the analysis phase of adding a bunch of language things and trying to see, hello, how are you? Yeah, it's been a long break, but I'm excited to be back into it. And yeah, this file was the entirety of my tests for the entirety of the development of the analysis phase, adding more things to try to see if passing them and analyzing them would succeed. My goal for those upcoming streams is to transform this into proper tests. So, yeah, let's get back into it. Because for now, we don't have a lot of tests. We have some very basic things. What do we have? Here I have some extremely basic thing of the encoding of characters for the Lexa. And I think, yeah, I have a few parsing tests. And what they do is they do a round trip, basically. I try to pass a file, I then pretty-print it back and pass it again, and ensure that this is working as expected. And this is not a very complicated test, but it did catch a few mistakes in the parser already. So what I want to do is to start thinking about what kind of tests do we want for the simplification phase. And I suppose the easiest way to do this would be to have two pieces of code side by side and check that the simplified version of the first one is equivalent to the second one. Now, one thing that's going to be a tiny bit annoying is I do not have equality instances for most of the representation of the result of the analysis phase on purpose. If I look at my AST, for instance, if we pass some kind of function and we have some statements, those do not have an equality instance. So I cannot just compare for equality, which means, which is on purpose again, because I want to avoid things such as comparing types for equality, because type checking is more complicated than just checking types are equal. Not having the equal instance means I avoid this entire can of worms. And again, there might be situations where parsing the same code results in things that are equivalent, but just would not match under equality. So for the simplification phase, I think what I could do is start with two pieces of code, one being the simplified version of the other, and check that. But this would not be a quick check test. This would not be a property test. This would be some hard-coded tests where we check that for some given input files, and we can add more test case as we go, we pass the complicated version and we pretty-print it. We pass the simplified version and we pretty-print it, and those two should now be the same. However, there's already something that is an issue there, which is our pretty printer that we currently have here expects a past version of the AST, which means we should probably think about doing a pretty printer for the resolved version post-analysis. That, or we don't want to do a pretty printer, we want to do some kind of serialization that is good enough to keep all of the relevant information to do the comparison, but doesn't care about being... Well, I guess that serialization would just be basically serializing to JSON the kind of... Like this would be the equivalent of that. This feels... Because it feels like serializing and then comparing text is kind of error prone. We're doing text comparison, which means if our serialization to text is slightly incorrect somewhere, we're introducing errors that are irrelevant to the thing we're trying to test. Do I want to simply introduce, for the purpose of testing, are those two things equivalent, and basically reintroduce test equality, basically? This might be the best solution. Are those things equivalent for the purpose of tests? But would that just be an equality instance on the AST, basically? And would that just be a lot of code for not a lot of benefits? Another option is to not do this comparison of here's the file, here's the simplified version, we pass both of them, we do the analysis on both of them, and we check that the results match, and we therefore don't have to decide what this matching thing would be like. And instead, since those tests are going to be hard-coded golden tests kind of thing, I just write, okay, we have run the analysis, here's what the resulting thing should be, hard-coded in the tests. But I don't like the idea of hard-coding this. I much rather have a file that encodes the expecting result for the test. This is a lot more readable than having to write code, and also it doesn't tie my test to a particular implementation of the AST, which means my tests are more reliable. They just test this code should be equivalent to this simplified version. Is the solution to just add an equality instance to all of my AST so that the output of the analysis phase can just be compared for equality? Maybe it is. Maybe that's the easiest solution. But again, what bothers me is we could very easily introduce some variance that is irrelevant that would be captured by an equality instance and make the tests fail, where in practice what they compare should be equivalent. We don't want a strict equality, we want those things mean the same thing, and that's a lot more tricky. Furthermore, as far as the simplification phase is concerned, unless I'm mistaken, we never simplify anything but expressions. We do not do any rewrite. So maybe, just maybe, it means that rather than having to rewrite an equivalent of equality for every single thing, I can just rewrite a basic equality for expressions. Actually, writing equality for expressions is the same thing anyway. Let's think about it for a second. Where could there be any variance introduced in the test that would mean that the equality instance would not be applicable for the kind of test we want to write? My immediate suspicion would be the unique name associated with something. Like, oh, this function that we have passed points to this function in this other module or something like this. And if it's assigned a different unique name, then we might conclude that those two things are different, despite the fact that they happen to be pointing to the same function. But names are not randomly generated. They should always match explicitly, like just a full path of the module and the type parameters. So that should be predictable. So maybe, just maybe actually, doing an equality instance on expression might be good enough for this kind of test. Okay, well, let's try that. Which means I am going to do that. I don't think I have equality constraints anymore. I used to have them. I don't. Okay. So I might want to introduce this back. As in, for a given phase of the compiler P, what are the requirements for a type to have equality? And it's probably going to be equality on a few things. And if I only want it on expression, maybe actually this is enough and I don't need the equality constraints. Let's try without using this, actually, and let's see. Expression. So here, what I want to do is to say, the varying instance, I'm going to have to put some constraints there. I don't know what they are yet. Actually, I am only interested here in the resolved expression. Could I just do that? And not make it EQ for all different phases? Possibly. Okay. I could also check. Yeah, I suppose I could check a few. Yeah, I have some ideas for tests. Okay, let's try this. Let's see if that even compiles with very few changes. Of course. So that would mean I need typed expression, because here expressions contain annotated expressions, which in the case of we're in the resolved phase, this is a typed expression, which is, and this is where we're going to run exactly into the thing I wanted to avoid, which is if I end up putting an equality constraint on this, then it means I am doing an equality constraint on the types. Which I guess for the purpose of tests is fine. My concern, again, with adding equality for types, which actually, do I have equality for types at all? Because if I already have it, then this concern becomes completely moot and I can just do that. I do actually have equality for resolve types already. Okay. Because my main concern is, most of the time for type checking, type equality is the wrong operation. I want to check that the two things are compatible. Because, for instance, I have on the left hand side a type parameter, and that is possibly a valid match for the right hand side, which might be an int, despite the fact that the equality instance would say no, those two things are different. Because, for instance, it's a generic function that accepts any number, and int is perfectly fine. So type checking is more complicated than equality checks. But I seem to already have equality for resolve types. I'm not sure where I use it actually. I am tempted to try, since it's been too long, I am tempted to try to remove this, which doesn't compile, of course, and I am tempted to remove this to try to see where we're using it. My gut feeling is we are using it as a key in some hash map somewhere, which requires having equality and ORD, but there we go, use of equal equal here in the function type. Okay, let's compile this out. Hashable, yeah, okay, that's probably why. Yeah, I think it's that. I need the hashable instance because I'm indexing some hash maps by that information. Okay, that explains. So it's just remove that. Okay, does that mean that I'm probably fine doing equality on expression resolve? Probably. I still don't like it, but I guess another approach would be to introduce a new phase parameter that's specific for tests that ends up having an equality instance. And I can introduce a new compiler phase, which is neither pass nor resolve, but like testable or something like this. And I redo all the mechanics there so that I can write an equality instance for that particular phase. And then I do not introduce equality instances for the other phases where those could be misleading. And instead, I can use them in tests and I can make them whatever I want. And I can even make that equality being a partial equality if I want. Like I can do things a bit smarter. But this is a lot of boilerplate. So maybe since I already have equality anyway for some of the key types, maybe it's enough to just, so typed expression, where are you? You're here. Let's try that. Okay, requires annotated expression resolved. Is that because it's a non-injective type family and the compiler is not certain that annotated expression resolved is a typed expression? So if I write it explicitly as such, will it be happy? And of course, this is the same thing here. This requires, because of the, if I look at the show constraints, yes, that's exactly what I have here. So maybe I can introduce the type constraints. To avoid having to type the same thing everywhere, I could perhaps just do this. And I would probably only need those two, I suppose. Oops. Oops. So if I do that, then I can go back to typed expression. Okay. And I can do the same thing for expression here. Let's see if this works. If yes, then we can start doing some actual tests for the simplification phase. Okay, that seems to be fine. So, what I will want to have will be a simplification file, which is going to be based on the parsing file I have here. Just going to copy all of this for now. I'm just going to do this. Okay. I might not need the arbitrary here for this. So list files will give me list files is something I've written here. Which gives me all the files with a given extension in a folder. And this is a template Haskell thing. So this will be done at compilation time, which means I am generated a bunch of tests. Well, the list is generated at compile time, and then this is a bunch of tests for each file that matches this. Here, I will probably want instead to match a bunch of files that have like two different suffixes. So I might need to do something a tiny bit more complicated here. Let's check that it finished compiling. Yeah, it did. Perfect. Because what I want to do here is I want to have two versions of each file. I want to have a file and the simplified version, and I want to check that doing the analysis of the files results in the same, that I can do an equality comparison on the expressions within. So there's going to be a lot of work there. First, I need to check. I'm using this golden versus string thing, which is this thing here from test.txt golden. Does it have a thing where I can instead That is somewhat annoying in the sense that there is no. Like, it generates an output and then checks against a golden file, which is, I think, not what we want here. Here, we don't want a golden test. We want, okay, we run the process on both files and we check that the thing is the same, not an output. So we might not use tasty golden here. We might just use tasty hunit with a basic assert equal there, basically. And I might maybe want to do something with lenses where for a given output file, extract all of the expressions within, basically. Okay, so everything here is going to have to change. In what order do I want to do this? So here, this will give me a list of files. I think I will want to sort them by do they contain, like, do they match something like dash simplified or something like this? Or maybe I can do something a bit smarter than that. Because it's not in and out. It is the raw version and the simplified version. I want to check that they are the same. Do I distinguish them with extension? I guess just like source. That gives me a list of files. For each of them, I get the base name, which will be something dash source. Actually, if I do a take base name, let's see, with something that has this. And actually, if I look at locate, I am doing this with take extension, which comes from one of those. Probably system file path. Let's try something. Any second now. There we go. If I do a take extension of something foo.bar.baz, let me make this a bit bigger. Okay, it takes only the last one, so I should probably not do that. So here, this will not work. Or rather, I should do this. That's the source. There we go. The downside of doing this is, if I do a take base name on that, okay. The downside of doing this is the files will not have the proper suffix, the proper extension from, which means the editing will not recognize them as proper source files. That's probably fine. I think I don't care. So here, what we need to do is a hunit test. So I think it's an asset equal or something like that. Because this is test batch. It is a property, if I remember correctly. Or it's a list of properties. And a property as defined by tasty. Okay, test case. Yeah, those are properties. The properties are for quick check thing, and this here is instead just some HUnit thing. I think. There we go, test case. So I need to make a test case, which would be a test name and an assertion. And the assertion can be an assert boolean or something like this. An assertion happens to be an IO thing, which means I can just open a do block and do a bunch of things there as much as I need. Okay, so here, this will be a test case. Is that the proper syntax? It is. And I will not need golden, and I might not need quick check just yet. And test case just takes the name, the assertion. So the name is the test name, and the thing here is the assertion, where I am going to try to read the source, which is the test input file, which I'm going to rename the source file. And read the simplified, which is going to be reading the simplified file. Then we are going to need to run the compilation, which means we need to run the full analysis of those things, which I will probably want to do in another file, like as a helper, because I don't want to rewrite everything from scratch every time. And then at the end of this, what we will want to do is an assert equal, which is not going to be a pure, which I can actually write with one of those operators probably. So it will be something like resolved source. How will this be named? Because one of them will be the simplified from the start, and the other will be the one simplified afterwards. So what names will they have? Simplified source, which is going to be our test value. So the question mark goes on the left, should be the same as the reference, whatever this ends up being. Okay, so it's going to be something like that. And here in the middle, we are going to need to have that. And this is going to be running the parser, running the analysis. So for this, we can look at what we have in our very, very, very basic main, which is there. One downside here is that for this phase, if we do on a one file basis, we don't have anything regarding imports or anything like this. But since the simplification phase only cares about expressions, and will not care about imports whatsoever, I think it's fine for the tests of this particular phase to not have more complex things than just basic files with basic functions, basically. Okay. So this is going to be the gist of it. let's go back to here. I think I have a... Yep, there we go. That is a helper file that has nothing yet in it, which is going to be... The idea of this file is going to be, for the sake of tests, perform the very bare minimum of each of the faces. So here I'll probably want to do something like parse, that given some text will give me some either string or something like this. Do I even need to specify? I probably need to have the file name at the very least, even though in a lot of cases it will be irrelevant. Yeah, okay. So it's going to be something like this. I'll have the file name and the source, and this will be a parse module with those two things. And on left, and this is going to just be a show, I think. However, this implies a monadic result, which I think is fine. What's the interface of the parsing phase again? Parse module gives me either parse error or module. That's perfect. So this is all good. Except on left expects... No, on left is incorrect. I want to do a map left instead. There is one in array, I remember. Control array. Arrow. Sorry, arrow is what I meant. There is a left function in there that does what I want. Do I have it in my prelude? I do have it. Okay. So I should be able to just do a left here. What is the syntax of that? It's going to be, okay, the function here, so it's going to be a left show of this, basically. Which, if it is correct, I'll be able to rewrite as using my good old friend, the blackbird. Okay. Then I will probably want to have analyze, which is gonna be... Oh, so probably gonna be a string, actually, come to think of it. This will be a module at the end. Analyze with something that takes a module and will give me either string or whatever the output will be. If I look at the interface of my analysis phase, here analyze module takes a bunch of things and gives me the diagnostics and maybe the resolve module. Yes, of course, it gives me both because I could have diagnostics and still have a result if all of those diagnostics are just warnings. This begs for a better kind of monadic context in which to call things, but I still don't have like an overarching architecture for the compiler. I have a bunch of faces that are like individual functions for now. So that's why for now I have something like this. But we can simplify that a tiny bit. However, I want to look at the simplification phase. What is... Okay, takes a resolve module, returns a resolve module. That is trivial, and I might even not need to introduce a phase for this here because it is just basically the same thing. So it's going to be a resolved module. So here, here we're just going to want to run the analyze module, and I think most of those things will not actually be required beyond the module name, I think. Where do I get the module name here? Okay, I just infer it from the file name. That makes sense, I suppose. I'm tempted, for the sake of this test helpers thing, introduce a very basic monadic context in which I can just chain things. This will make things a lot easier. Okay, but what are symbols, functions, and so on? Are there things from my context? Yes, I get them from my current state. Because there are things that are exported that by previous modules required for the import, which actually, do I want to emulate this for my tests? Because the problem will be some of my tests will require testing incremental compilation or like multiple modules and everything. And for those tests, I will need to have a proper pipeline. But at this point, I think if I get to that point where I'm not testing a phase in isolation, what I will want to do is, rather than emulate the behavior of the compiler, I will want sorry, I'll just finish this and then I'll answer your question. I think if I get to a point where I want to test like multiple stages, compilation and everything, like the different modules that end up depending on one another, rather than re-implementing the compiler logic of keeping a cache of the different things that have been compiled and everything, and re-implementing a second version of the compiler for the tests, what I think I will want to do is just use the actual compiler from like an end-to-end test perspective, with just having some output after the different phases, which means I think I don't want to redo this. For your question for Linktree, I have not had a lot of feedback on it. Like, I don't think anyone has ever told me like, hey, your Linktree is good or anything like this. I find it useful in the sense that like I can just give one link and there's all of my social media, all the things, and I can reorder in which order they appear. So like Twitter is no longer one of my mains because I'm no longer really using Twitter, for instance. It's nice to just have like, here's a link with everything basically, which I guess my old blog kind of is as well, but this is like a very simple managed version that I don't have to really care about. I find it useful from that perspective, but it's not like I've had a lot of feedback on it. But yeah, I have spent like half an hour one evening just setting it up, and I think it looks okay. So yeah, I think I am not going to bother re-implementing all of this caching mechanism for dependencies. I think when I want to actually test that kind of like complicated compiler behavior, I'll write end-to-end tests instead, which means I'll have to make sure my compiler has a way to output the result of every phase independently, so that we can test them. So I think for the sake of this, I am not going to bother with keeping a cache of any of this. I think the only thing I might want to do is, since this is all going to be only one module, I might just do a test compiler M, which is a monad reader of text M. And which means all of those operate within, so compilers no longer exist. Parse will be operating within the scope of a test compiler M. So this is something that has access to text, which is going to be the file name, and something that can output a string, which is the error, which is just going to be like simplified to string for the purpose of this. Now, parse becomes, given some monad M that happens to be a test compiler, we get the source file and we output the module, which means now I have to rewrite this. Sadly, the blackbird is going to go away. This is going to be the source as an argument, and the file name will be obtained from the context. And now this is just going to be this left show, however, makes an assumption about this being either, which is not the case here. However, control monad error. Except is the one I want. I think this is just a matter of, yeah, lift either is what I want. So I can do a left show of this file name, or actually even here, even better, I can do source, and here on left I can do something which is just a throw error of show. Okay. Or I could do this as a lift either, I suppose, but I think throw error is the easiest. Okay. Perfect. Now analyze, we can do the same thing. We are going to be in some arbitrary monad that happens to be a test compiler. We take now a module, and we return a resolved module, and this analysis, given some module, some parsed module, is going to be we are gonna do a call to analyze module with, oh, the only thing is I need to check those definitions and everything do not, no, they are all empty. Okay. I was wondering if they were initialized with like the built-in things, like the system-defined prelude and everything. They don't seem to be. So that's perfect. This is just going to be MMT for experts, definitions, symbols, and functions. That makes my life a lot easier. Okay, definitions, symbols, functions, exports. Perfect. Now I need the module name, which I'm going to make a local helper for this. What have I used? If I go back to, I've used this. The module name is something that, given some test compiler monad M, will give me the text of the module name, because I think module name is just text at the moment. Let me check that. Module name, where is that defined? That be name? Module name, oh, it's a non-empty list of identifier. Okay, so no, I was wrong about this. So this is gonna be giving me a module name. And module name will be, let's get the file name from my reader context. And let's do the same thing that we do at the moment. Module name. Oh. Good enough. Which will require, of course, having... I don't need all of that, but I'm going to put all of them here, and we'll see what we actually require. Okay. Okay, so here we need the module name. Which we get directly from the helper function underneath. And then we can do our analyze module, where we give that name and the past module, which was our argument here. That gives us... What does analyze module give us? It gives us this thing. For the sake of tests here, I'm going to ignore warnings, which is not great, but I think for the sake of tests, that's good enough. Which means I am only going to show an error in the case where we don't have a result, meaning we actually got some errors. Okay. So here, this is going to give me a pair of diagnostics and a result. And what I'm going to say is that this is result, and on nothing, so we don't have a value to actually use there as our result, then we are going to output some kind of text that describes the issue, which will be show of diagnostics. Okay, that's good enough for tests. And then I can do a simplify phase, which is going to be the same thing. Which, given a resolved module, gives me a resolved module. Okay, the noise cancellation works. And this is going to be... Here, there's no possibility for errors, so that's very convenient. This is going to be trivially a... Okay. By making it monadic here, there's no point in doing this, but it's just I'm providing an interface through this file, which means the rest of the tests don't need to actually depend on the actual interface from the different faces and can use this, which means the rest of my tests don't have to change if the interface to the different parts of the compiler change. That's the goal, at least. Okay, so that should be everything that we need. For now, at least. Of course, I'm going to need a surprise. Oh yeah, I suppose this contains everything I need. Probably. We'll see what's missing. Oh, wait, wrong file. This one. There we go. Okay, so that should be enough of an API for my test. So, simplification, let's go back to it. Not this one, the other one, the test one. So what are we going to do? Well, we are going to need to do... We're going to need a test monad that happens to be compatible with the thing we have described here. Which is going to be basically a reader monad stack on top of on a error monad of either, basically. Of an accept T, I suppose. So here, this needs to return something that is in IO. So that means we are going to do we're gonna do a run reader T. The question is, how do I handle errors there? If anything short circuits, it should be a failure. What's the expecting way to report errors in each unit when things go wrong? Is it just fail? It's IO, it's probably just fail. Like asset failure here is probably just okay, it's actually just even. But I guess asset failure is a thing I have access to, so maybe that's what I want. That means that after I'm done with this, run except T, I suppose. Then the stuff goes here, then. Here at the top, I will have to lift this. Might even have to lift IO this, actually. Okay. Oops. So here within this, which is the assertion monad, which happens to be basically IO, but let's behave like I didn't know that. We are going to do a first thing, which is going to be running the compiler phases. I'm going to introduce a helper for this, I think. And I want to do it twice, which is going to give me the thing. Okay, so let's actually introduce a run test compiler that will give me, given an accept a reader T of text, of an accept T of string, of some monad M, and will give me an M either string A, and this will need the text as well. And this is going to be so given the file name, this is going to be run except T of flip run reader T of the file name, which means it is that. Okay. Okay, so here I am in the test monad, and I can do the reference is going to be run test compiler. I can do this directly in IO, it's going to be easier. The reference is going to be within the test compiler, pass the simplified version, and perform the analysis on it. So this is just analyze of pass simplified. And then our simplified source, which is a bad name, test value. Test value, suppose. Test value isn't the worst thing. Is gonna be we pass our source, we analyze the result, and then we simplify the result. There we go. Which I might rewrite from left to right, actually, just so that it aligns a bit better and the symmetry is more obvious. So the reference is just we pass the simplified version, we do the analysis. For the test value, we pass the source, we do the analysis, we simplify. And at the end here, we run the test compiler, so that gives us an either in every case. I can go one step further, and I can do here that this actually gives me an MA. If this is not an M, but actually we are in the case of but will always be in the case of HUnit. No, I think I'm gonna keep it that way. And here I'm just gonna do on left M. And again, this is assert failure. Now that means the test will fail. This test case will fail if we fail to run a test compiler for any of the two files. At the end, I will get, hello. Welcome, everyone. So, this project is a project I started months ago now. I am writing a compiler for a made-up language, but that looks a lot like Rust. And the output of this compiler is not just a binary that you can execute, it is in another language. Specifically, I'm targeting an esoteric language called Piètre, in which the source code is an image. For instance, this here is a valid Piètre program, which happens to just like print 2 characters to the console and exit, which was generated by the backend of the compiler, so already from like bytecode. And the goal is to take Rust-like code with like generic functions and multiple modules and incremental compilation and all of that, and at the end, generate Piètre images like this. Because this is a stack-based language underneath, which, you know, perfectly fine Turing-complete language. So in theory, we can absolutely translate any complicated language construct into something like this. So I'm operating within a much, much simplified version of Rust. There's a lot of things that are not there. There's no lifetime. There's no dynamic memory allocation. There's none of that because we limit ourselves to things that we can easily then express in a purely stack-based language like this. We, at this point, I'm just back from like a long break over the summer, but at this point, we have the Lexa parser already working. Just before going on vacation, we finished the analysis phase, so name checking, type checking, and so on. I've already done the backend phase, which means given some bytecode, generate an image, which is how I've generated the image you've just seen. What is missing is, well, the everything in between, as in lowering to the IR and then doing code generation. For the IR, I have not started at all. For now, I'm planning to target something that's going to be close to the LLVM IR. Although there's probably going to be some differences, including a lot of simplifications, because there's no reason to be as complex, because again, I'm working in a much, much simpler ecosystem. And then code generation will be, I have this IR on one hand, and I have my bytecode that's already ready. How do I translate one into the other, basically? For today, since I'm just back from vacation, what I'm doing is I'm writing tests for the analysis phase and the simplification phase that I have finished before going on vacation. So no big progress on the big theoretically complicated things. This has zero real-world use case because no one actually programs with Piètre. My goal, however, I'm keeping an archive of every single stream, and the goal of the project is to never write code outside of the stream. And the idea is to provide kind of like both not a tutorial to Haskell. I'm already assuming some familiarity with the language, but like an example of a large-scale project in Haskell. And also, even though the languages I'm targeting are made up and don't have any real-world use case, I'm hoping that this whole project, can serve as a decent introduction to the concepts that are used in a compiler. So even though all of the languages are made up, I'm taking this as seriously as I can. I've been using Alex and Happy for the parsing and lexing like GHC does. Like, I'm trying to stick as close as possible to a real compiler, even though this is a made-up language and a made-up project. So to read a picture, that's not my part. I'm generating the pictures, but the Piètre interpreters do read a picture. What they do is they segment the picture in cuddles, which are like this large groups of pixels of a given color, and the interpreter starts here in the top left corner and then moved at first from left to right, and each transition of blocks of color is interpreted as an instruction. So this cuddle of 1 into this color will be a push of 1 on the stack. The thing will then go all around the image. Here there's another push of 1, and then this transition, I think, is a rotate to make it rotate the expression, the execution to go then in that direction. This strip is a series of instruction that does compare the current value at the top of the stack with an address that will map to one of those entry points in the different functions, because each entry point in the function will be assigned a unique address. So this assumes the top of the stack is an address. If we are something that is less than the current number of entries to that function, we redirect the execution that way, otherwise we continue, and so on. If you give it a random picture, like the Piètre interpreters will try to run it, but will probably just fail, because it's very likely that if you end up having a valid sequence of instructions, you will try to do a pop on an empty stack and it will just throw an error. Or it will just loop forever. But you could try to just give random images. Actually, let me show you something. Here is the page that introduces this esoteric language, and it has it explains. It's linked from the GitHub page of my project. It explains how Piètre actually works, and it has a few examples, sample programs. There we go. This is an hello world, for instance. This computes Fibonacci numbers. This is, again, purely the transitions in block of colors that makes the image. And some people have done some very interesting stuff. That's a hello world. That's more hello worlds, and so on. So yeah, that is the language I'm targeting, not the one I'm starting with. The one I'm starting with looks a bit more like Rust again. Here's a test file I've been using. So here you can see structs with type parameters. functions that have type parameters themselves, constants, and arithmetic operations, and so on. And the goal is to take this and compile this into, that. So that's the project. And again, with the goal of both being an example of a large-scale Haskell project and being a introduction to a lot of the things that go into writing a compiler. Yep, I am writing the compiler that creates a picture. This picture there was created by the backend of the compiler, not starting from an actual file because I have not finished the compiler yet, but starting from some bytecode. My bytecode looks like this at the moment. I have a bunch of instructions, which map basically almost one-to-one, not exactly one-to-one, but almost one-to-one with the instructions supported by the Piètre language, such as push an int on top of the stack, push an address on top of the stack, pop the top value of the stack, add the two values of the stack, and so on. So I have this list of instructions, and I have something that is able to generate an image based on a list of functions that are made of those instructions. And you can see it here. Those are the two blocks here are the two different functions. This is an entry block, which is this entrance kind of thing. Some of those are like add or maybe print. This here is a branch instruction that does this thing that exits to the left here, and so on. So I have this backend part. If we have the bytecode, we can generate an image. I have the start of like, given a file like this, we can lex, parse, do the analysis. I am missing at the moment the everything in between. Like, okay, we've analyzed this piece of code, it type checks the name resolve. How do we generate the bytecode that we can then make into an image? No, the bytecode is not really meant to be human readable, although in practice, it will kind of be, because I can just show it as a list of those different things. So I can show that a complicated function will be a list of like, push, subtract, multiply, divide, and so on. But it's not exactly intended to be human readable. Although what I want to do is to try to have every stage of the compiler output something that can be human readable in the same way that a lot of compilers do. For instance, I will want the LLVM IR, the IR of this project, which will be close to the LLVM IR. I will want to have an output that generates a graph, like a dot graph of the different functions and like the control flow graph, basically, which is the same thing that like LLVM does. I'm planning to have that there where every stage can be visualized in a human readable way, but that's just a visualization, basically. Some side goals of this project include, since the IR will be based on the LLVM1, I'm kind of tempted to, bytecode is a very generic word. You can use it for whatever you want, right? So like this will be basically, this can be encoded as something that fits basically on a byte almost, except for the addresses. So this could be encoded as a kind of binary format if I wanted. I'm just going to bytecode because it's convenient. And again, I will want some of the side goals I have for this project. I will want as well to do a thing where, since the IR is going to be based on the LLVM1, I will also want to do a thing which is convert my IR into the actual LLVM1 so that we can compile for real as a binary the code in our made-up language, so we can compare the execution by compiling into a binary and by running it as an image. So yeah, that's the project. And someone has mentioned brainfuck. Yes, I love brainfuck as well. A thing I do on this channel as well is I usually do the Advent of Code every December, and I usually do it in Haskell. But when I'm done with Haskell, I sometimes do the Advent of Code in brainfuck as well, because that's fun. Yeah, this is not a Scala clone. This is like a much simplified version of Rust. No lifetime, no dynamic allocation, none of that. And well, thanks. Yeah, it's fun to do. The only thing is, at the moment, my generation function is very basic. If we like put all of the functions like this aligned as columns, but something we could think about in a future version of the project is, okay, we know what the color scheme needs to be, what the color transitions need to be for this program to work. Can we make it into a better image? This is currently Manjaro Linux, which is based on Arch, if I remember correctly. It's been a long time since I've cared about which distro I'm using. It's just a very basic Linux thing. It's just my IMXFC config and my Emacs config have followed me for, at this point, 2 decades. So I just copy them from one machine to the next. But yeah, that's the project. And this evening, I am writing tests because I've done all of this analysis phase that does the name checking and type checking without actually having proper tests for it. The only thing I had was this file and trying to parse it and compile it and see if it worked. But I don't have proper tests for it yet. Yeah, this is not, my goal here is not to try to make like a very, very small compiler. This is a big Haskell binary with a bunch of things. I am not optimizing for size. Optimizing for size is fascinating, but that's a very, very different kind of project. Here, I'm going for like, no, I'm bells and whistles and very, very verbose and as much as I can trying to make readable code. I'm not sure my analysis phase is that readable. That's the thing I'm doing this week, being just back from vacation, is try to clean things before, exactly, verbose is good for learning. My goal this week, before starting to tackle the IR stuff next week, or maybe in 2 weeks, is to do a big bunch of cleaning and documentation and testing, basically. Try to like leave what we have done in a good state before I move on to the next phase. Thank you so much, and thank you for your opinion. So yeah, I was in the process of writing here some very simple functions for the purpose of running some compiler phases in the context of tests, which means here I can go back to writing test cases for the simplification phase, where I run a test compiler on the reference, which is just I pass the simplified version and run the analysis. And here for the actual test value, I pass the source, I run the analysis, and then I do the simplification. And at the end of this, my goal is to test that this test value is the same as the reference. And this will be as simple as doing this. So that should be all I need. Except no, that's not true. Here I am missing one thing. Run test compiler takes another argument, which is the file name. So here I need the file name, which is just the test name in this case. Unless that's already the base name here. Fake file and name is gonna be test name plus the extension, and I'm gonna use that in both cases. Fake file name. Okay, there we go. That should be all for the test. This does an additional thing. I am using some template Haskell magic to collect at compile time a list of tests coming from a specific folder in there. So I think before I can finish this, I will need to add here a simplification folder. And let's add a basic arithmetic. Oh, this is not going to be correct. This uses equality on the module, but modules do not have equality unless I end up adding equality everywhere anyway, which is something I was kind of thinking of doing. Okay, I need to think about it. So for now, arithmetic.source. This will contain a function foo. Text no argument, returns no argument. And this will return 1 plus 0 divided by 1 times 1. create the folder. There we go. And I said that the simplified version should be the simplified version. This should be equivalent to return 1, basically. So this, oops. This should get simplified to this if everything works well. Okay, so now the only thing that's missing here is this equality test here is not going to be correct because it is assuming that I have equality for everything in the output of my test compiler here, which is not true. I don't. And that's because the output here is going to be a resolved module, which is this thing here, which contains the set of exported identifiers, the list of definitions, the list of symbols, the list of functions. And here I am only interested, I think, in the definition cache. What is a function cache again? If I look at stages analysis monad, function cache is for a name, okay, the scope, okay, and the past information, which is of course used for generic functions that need to be resolved at a later stage, of course. Yes, so it's the definitions I care about. So here, what I want to do is I want to compare the definitions. Definition cache is a hash map of name that contains for the location a resolved definition. Okay. So basically what we're going to want to do is, if I look at this, I'll need to get, so the definition cache is what I want. What's the accessor again? It is not here. It is in here. It is res mod definition. Of the test value. And reference, so ref definitions from the reference will be the definitions of the reference. So I want to compare those. I don't care about anything else. That's the thing that this test is trying to compare. Now, those are hash maps. So let me see if I have, because I don't want to just compare them for equality, I want to check that they have the same keys. Is there some way of That's not exactly what I want. I could check that there's no difference first, as in, oh, some of those like things don't match. That's probably not what I want. because there's an easy way to do this, which is I collect the set of all keys across the different definitions, and then I just go through all of them. But that feels... Yeah. Yeah, I think that's what I'm going to do. I think it's the easiest way to do so. So, I will need... So here, what I want to check is, I want to... So all definitions will be the union of the key set of the test definitions and the keys set of the reference definitions. And now for each all keys, I suppose, rather, all names, because I know what the type. So for each thing in all names, I get the name of a definition, and I can do something for every definition in those two files. I can get the definition and here I can do, since this is a test, I can do a hard lookup. If it fails, that's fine. The test will just crash. That's fine with me. Like key not found, that's perfectly fine. This will be caught by the test runner. So I can do ref definition will be doing a lookup in the ref definitions of that name. No, I do not use AI at all for any project, and not for and even less so for this project. For this project specifically, I think it's a bad choice, and I have strong opinions, personal opinions, against AI at large for more general projects. For this project specifically, the goal of the project is again to try to provide an example of like how compilers work, but also all the works that goes into making one. If the streams were just me asking a code generation thing to generate the code of a compiler for me, I feel like a lot of what gives this stream some value would just go away, because I would not be doing much else than what you could do on your own, basically. I guess I could provide the expertise of being able to criticize the output, whether it's correct or not, but I feel like if my goal is to showcase what kind of work goes into making a compiler, asking a tool to generate it for me kind of defeats the purpose. More generally, not just for this project, I don't think using AI is a good idea. There's a lot of reasons why I think so. The first is like you delegating a task to a tool makes you less good at that task. That's not a surprise. That's true of a lot of tools. There is a reason I'm terrible at washing clothes, is because I delegate that task to a machine because I don't think that's a very important task, and the machine does it better than I would. But AI generating stuff is, first, not that great at writing code, far from it, and two, using it regularly makes you less good at that task. So even if they were good at this, as a person who cares about the craft that goes into this, I don't want to get into the habit of delegating my thinking and all of this to a machine that, again, at the moment, doesn't even perform anywhere near close to a human on that. And of course, there's also all of the other reasons not to use AI, such as the environmental reason. It's hard to quantify the amount of carbon emissions that result from one query to an agent, but what we know is that the big tech companies that had a lot of commitment to reduce their carbon emissions have instead increased their carbon emissions by like up to 30% because of the increased demand by those AI models that are extremely like require a lot of energy. So there is the environmental reason, and there's also the ethical reasons. The fact that currently those AI companies are using training data that was acquired unethically. Copyright is a complicated issue, but it's fairly easy to point out the fact that there's kind of a double standard where if a person accesses something without respecting the license, they can get fined into oblivion. But if a big tech company steals a bunch of data to train their AI, then it's fine, right? So that there's this ethical issue, and then this thing that has been trained on stolen data is used to replace the people whose data was stolen. And there's the political thing, where the people currently selling AI models are willing participants in the rise of techno-fascism in the West, and I don't want, even if there was no ethical issue, even if there was no environmental issue, even if using AI was not bad for my brain and did not devalue my craft and did not steal labor, I wouldn't want to use AI in the current climate because the companies selling it are companies that are currently contributing to the rise of surveillance capitalism and techno-fascism. So, no, I don't use AI for coding for anything, and I cannot wait for the AI bubble to finally burst when everyone realizes that there's just no money to be made in there. So yeah, that's the short version. And also, again, because I want to also substantiate some of the claims, when I say it's not as good as a human, LLMs are stochastic parrots that at best regurgitate the things they have been trained on. They are not very good at writing stuff, and we're approaching the limits of what they can do, and they perform best when there is already a lot of similar things in their training data, which means if you ask them for like scaffolding for basic projects or showcases, example things, they tend to be pretty decent. However, the second you go a bit deeper or your project goes larger, there are a lot less matches in the training data and they perform a lot less well. For Haskell stuff, as long as you ask them very basic things, they tend to be okay. But the second you ask something a tiny bit more complicated or with a bit more context, they just respond complete nonsense. And since they tend to be programmed to be very sycophantic and always say yes, they will say yes and output something that just doesn't work. So again, even if they were good at writing code, all of the other reasons make it so that I wouldn't want to use them, but they're not even that good at writing code beyond the very basic and the very obvious. So, yeah. So here, back to the thing, I have extracted all of the definitions that appear in the parse value on the left and the parse value on the right. Here, I just do a hard lookup. This will panic if the name is not found. So if my test files don't match and there's a definition in one that's not in the other, this will crash. That's fine with me. This is purely a test. This will be caught. This panic will be caught by my test runner and the test will just fail. That's okay with me. And here I'm doing this thing where I compare the test definition with the reference destination, the definition. Will that actually be okay, or does this need to be? No, I'm associating. Yeah, okay, this is fine. And yeah, I know that I'm currently looking for a new job, and the problem of being forced to use AI tools is something I really want to avoid, and it does restrict my job search quite significantly. Because I don't want to use those things. I don't want to contribute to them. I don't want to be stuck with tools that are going to be deprecated in hopefully months when the bubble pops. No, I don't want to be stuck with that. So it does significantly restrict my job search. And yeah, if you're stuck with using them at work, you have my sympathy. A lot of my friends are in the same situation and are like enduring every single day until the bubble pops, and it sucks. So yeah, I'm sorry. And it's very hard to argue with leadership when leadership is just convinced that this is good and increases productivity, no matter how many studies show that it's not the case. So, yeah. So I think this should work at the condition that we define an equality instance on definitions, which is something we don't have yet. But at this point, earlier in the stream, I was thinking about, do I want to add equality instances to like be able to compare for equality, things of that nature? And I was against it originally. The reason being, there's a lot of places during the type checking and the name checking where doing an equality check is wrong. For instance, checking that the types match, doing an equality check is not correct because there are situations where type checking should succeed despite the fact that the two types are different. For instance, if a function accepts an argument that is a generic type, t, for instance, because it's a generic function, then giving it an int should be fine. That should type check, despite the fact that type parameter t and int are two different things for which an equality check would say false. So not having the equality at all prevents writing code that tries to do equality. So at first, I was strongly against adding equality just to prevent that kind of mistakes from arising from the code. I have relaxed this a tiny bit and I have started adding equality constraints in some places. And I think I'm just going to bite the bullet and I'm just going to add equality constraint to definitions, which is something I wanted to avoid, but I think it's fine. So here, this would be, if I go to definition, I'm going to need to do here, if there are equality constraints for a given phase, then we can define equality for that given phase. And that's going to mean putting equality definitions on basically everything, but that's fine. I am tempted to try to do, whenever I have this, replace it with the same thing, and okay. Okay, let's try that. This means I can remove that then, and move that here. Okay. Let's see if this compiles at first, because I've already made a bunch of changes to the AST. Let's see if overlapping expressions. Wait, and this line? Interesting. Or is it because, no, it's the error comes from this line, but it comes from the fact that expression here, yep. I already had defined an equality constraint, and therefore it was slightly wrong. Okay. Okay, and now that means here I need to expand my equality constraint to basically be the same as those. Okay. Here that's going to be just a problem of okay, yes. I'm just going to do this again, same thing here, and only make the ORed instance for the resolved thing. So it's going to be the same here, I suppose. Wait. Oh yeah, okay, those are here. I'm just going to move them here, remove the EQ here. There we go. Okay. Does that mean? So here it's complaining that it cannot find. So do I need to just do the same thing here? Yeah, I probably need to do this because basically it needs this to have equality, and for that to have equality, then it needs this constraint. So I probably need to do that, which means I probably need to do the same thing here. Except here, this is no longer, yeah, I'm gonna move this because in this case, this is for resolved. Exactly in the same way that it is here, this is for the resolved phase of the AST. And here I forgot the arrow. Okay. And here I suppose it's going to need the same thing. And that should be all, hopefully. That's... Is it the proper syntax? For ORed, is it deriving instance? Yes, okay. So it is that syntax. Okay. I'm not expecting the tests to compile, but I think hopefully everything else should. So here I am going to need to do the same thing, which is a bit annoying. I'm going to need to do this. Because now the fact that those things have EQ is based on some constraints which are more complicated and involve non-injective type families, so the compiler gets a bit confused, so I have to be a bit more... this is annoying. Wait, why is this... Do I really have... Yeah, I do have undecidable instances in there. That's not great. So what undecidable instances is, it is a language extension that disables a very basic check. The idea is this. When you do instance resolving, like this, or like you have a constraint in the instance and so on, the compiler wants to be able to guarantee that this search will terminate. And as a result, what it does is it prevents some kind of substitution on the left-hand side where you could potentially substitute something that like ends up being itself. Because if you end up having this, there's no guarantee that the thing will terminate. So by default, instances substitution and constraint substitution has to always substitute to something smaller to guarantee that the thing will terminate. Undecidable instances removes that check and basically tells the compiler, don't worry, it's fine. This will always resolve. It will terminate. There's no infinite loop here. However, if you get it wrong, the check is no longer there, and the compiler could, in theory, do an infinite recursion trying to solve this. And that's because I have type families in this nonsense. That's why I end up needing undecidable instances. And here I'm going to need the same thing. I'm going to need the EQ constraints for this to be hashable. Okay, and that means I have some issues in my boot files. This is starting to be extremely annoying. Maybe I will not want to do all of that. I wonder if that's big. Oh, unless it is enough for me to do so. And to say, well, those instances are not defined. And that's the problem. I need them for, That is frustrating. Okay, so that means I don't want to do this. I want to be able to keep this. Which means I want to be able to keep this. Which means here, this might have to go away. Okay, so I've removed all of my EQ constraints line, in theory. Oh, it doesn't seem to have worked. Okay. Okay, so what do I have if I go back to what I've changed? Before I changed all of this, I had this, and this was enough because it did not revolve around. Okay, so I think what I need to do is I can keep the same logic, but if I only do it on a resolved version, then I can reduce the constraints. And if I reduce the constraints, then I can keep the other file without having to put a bunch of constraints in it. Okay. So that means I want to do something where EQ constraints, I'm going to do it with a reggae. No, it's fine. It's always the same spacing. EQ constraints. He's replaced with nothing. Okay. And now I will want to replace EQ a bunch of things, a bunch of space. Wait, what's the syntax exactly that I want to replace? I want to replace... Ah, there we go. I want to replace EQ a bunch of spaces, some name, And I want to replace this with resolved. Okay. Okay. Is that all? It should be all. Of course, some of those will be missing some constraints, and maybe I can only add the constraint for the ones that actually require it. Here I have a bunch of remaining EQ constraints. I don't know if those will need it or not. We'll see. Okay, let's try this. Let's see what's missing. So here I would need it. So can I do an EQ constraints here? For this, would this work? Would this be enough? Or does this create more issues? That's interesting. Oh, no, okay, yeah. But why is it for ORD and not for EQ? That's fascinating. Interesting. There's another solution, which is I do none of that nonsense, and I rewrite... Because this nonsense is getting complicated for very little benefit. Maybe, just maybe, I go back to what I had. I remove this. I remove EQ constraints everywhere. I can almost, I think, just revert the file. Not entirely. Typed expression will be required. Type alias info, perhaps. No, this one is not required. Enum info not required. Struct info not required. Function info not required. Yeah, no, I'm just going to revert all of this. This is not the right approach. This creates a lot of complexity for very little benefits. Yeah, okay, and I think this can be removed. No, actually, this is better the way it is. Okay. Okay, let's try this again. Hello. How's you? So here I'm going to need... So this is, again, the problem of since I don't have... Since the type families are non-injective, I need some constraints, but here, rather than making a equality constraints kind of thing, I'm just going to write them manually for where they are needed. So this is annotated expression resolved. Okay. And I'm going to need this somewhere else. I need it here. And that should be enough. Hopefully. without having all of the craft I was adding. Okay, but that means that my tests do not compile yet. That's fine. Because now it means if I go back to the simplification tests I was writing, here this requires an equality definition for an equality instance for definitions, which we no longer have. So when it comes time to compile this, this will fail. So instead, we are going to want to do I am missing a few things here. Import locate, and I need to import compile. Here, what I'm going to want to do is I'm going to want to iterate over those things to extract all of the expressions within, to then do a pairwise comparison of the expressions, because I will have equality comparison for the expressions, but I do not for the actual definitions. Now the question is, can I write something that extracts all of the expressions from within a definition as a lens? Oh, yes, I'm gonna here need import data hash map strict qualified as M. And this comes from a module that's not part of the big export. Name, I believe. Draw. Okay. Yes, what is this arrow? This is wrong. There we go. However, I will need some kind of constraint. I think I need at the very least a monad M. Okay. I suppose indeed this needs to be a file path, which means this needs to be a file path, which means this needs to be a file path. Okay. Ah, yes, of course. Analyze module here is not returning something in a monad, so I'm going to need to deal with it in some way, because yeah, actually this is just this. It doesn't return something monadic. So instead I need to do that and then do this thing to put it in the monad. Okay. So something here is wrong. So if I put all of the arguments explicitly, this should be Is that correct? Missing one pure here. That's what it is. Okay, so this should be fine now if this function fails. Okay, error in use import, that's fine. Oh, and simplifier is not part of the exported functions. Okay. Redundant constraints, interesting. Defined but not used. Yes, I need run test compiler to be exported as well. So that's the code. That's the test code we wrote earlier this evening. And we're back to, okay. And now there is no equality definition between a definition there. Okay, I'm curious about something. I am not familiar enough with lenses to know how to do this. Can I basically use... I have prisms on the constructors of the different definitions. Can I use that to write an expression that will route using prisms whatever definition to the proper subfunction that will extract something? For instance, let's say I have a const info. I have a const definition, which contains a const info. Which is going to be the past version, I suppose. And the const info contains an identifier, which is going to be foo because I have 0 imagination. A path info, which is going to be the type, which can I use? Can I use int type? Perfect. It's going to be an int type, and it's going to contain an expression which is going to be an int literal 1. Except that's not int literal expression. There we go. Okay, and this needs to be a typed expression, and that's a typed expression with an int type. Okay, just still not happy. Because in the constant definition, the constant info, the expression is an annotated expression, which for a resolved is a typed expression, which is this thing here. That indeed contain more things. So I'm saying it's an L value expression. No, it's an R value expression. Cannot be assigned to. Okay, so that's a definition. It's a const definition for a constant foo. It happens to have a type which is a int, and it's not an L value, and it's an int that contains an int literal expression 1. Okay, now, if I do this definition and I use lenses to look at the const info, what do I get? I do not get anything because I think it's within the square afterwards. No. Oh, I perhaps just don't have prisms for them, actually. Maybe that's the problem. No, I do have... Oh, I have prisms, but no, I have prisms for definition. Okay. Control lens. Let's go to control lens template Haskell. Make prisms. Okay. What's the name gonna be? It will create with an underscore. Okay. So if I go back to definition, because I have prisms for definition, it means underscore const def should exist. Oh, yeah, of course. I was using the wrong name. So this should give me... Aha, it's giving me... So it is extracting the thing correctly, but it is giving me something... It expects something to be a monoid in the output so that it can construct an empty value. So if I do this... Okay. So it should be possible. I should be able to do something that extracts all of the expressions using purely lenses. At the same time, this feels like it's going to be a nightmare to maintain, so maybe I don't want to do that. Maybe instead of doing something as nightmarish, I'm just going to make a local helper function. Extract expressions, which given some just expressions, that given some definition resolved will give me... I am going to need to have access to the AST. I am going to need to have... This is going to give me a list of expression resolved. I guess typed expression resolved? Yeah. So a list of typed expressions. Okay. So this is going to be a concat map of a case. And here I'm going to have to do a bunch of things. Let's do it manually. Only const definition and function definition will have expressions. Everything else will give me nothing. So in those two cases, there are expressions I need to return. In the case of a const info, that is purely the const exp. That's convenient. And in the case of a function info, then it becomes the same thing for the statement. Because it becomes now, oops, if I go back to the AST function info, for each of the things in the function body, I'm going to do a concat map of a case, and for each kind of statement, if for while let will contain expressions, return as well, but those two will not. If it's an expression statement, that's very convenient because that means the result is just that expression. I'm going to use pure for consistency. If it is a return statement that contains a maybe expression, that is a maybe to list. I can do a fold, I think, for this, of the expression. Is that correct? If I fold... No, I think that's not correct. That's only correct if the thing within is a monoid, which it is not. So I'm going to do a maybe to list. In the case of any of those, if it's... I'm just going to do this, and I'm going to do this. If info... Well, there's going to be one which is going to be the if expression. That's an expression. That's what I want. Which will be appended at the beginning of the list obtained by... Okay, so I'm going to do this, and I'm going to introduce a new function instead, where go is a case. So here I can do concat map go on the if body, and do this on a fold statement. Okay. From statements, and this is going to be a fold of an F map. I want to map something in the case where the maybe is not nothing and do a fold on this. Doing a maybe is doing a maybe better than doing a fold, or a fold map, actually. Maybe a fold map is what I want. If I do a fold map, given something that points to a monoid, yeah, okay, I want to do a fold map. That's what I want. I want to do a fold map of from else on the if else. This will map something on the if there is value, we'll map something which is a monoid, which is a list. Otherwise, will give me the default empty monoid, which is the empty list. Okay, perfect. In the case of a for block, I need... This will be the for range exp, which will be at the beginning of a from statement. Actually, I'm going to do a from block because I will want to actually... here remove the location. Wait, no, because I am in the resolved case, and in the resolved case, do I still have the location information is the thing. The annotation for... yeah, it is. There is no longer any location information. Perfect. Which means I don't need... I can just leave this, but from block is perhaps more readable. Okay. Okay. And from block... which is the for body. For while, it's even simpler. It's the while expression, and from block of the while body. For a let statement, it is simply going to be the let expression. For return an expression, it's this. Let me just check that maybe toList is something I have in scope, actually. It's in data, maybe. Do I have it in my prelude? I do have it. Perfect. So I have access to it. Okay. Just gonna align this for convenience. I'm just missing a from else, I think. Which is also going to be a case. If it's an else, if of an if info, it's going to be duplicated code, but it's just for tests, and it's ugly code in the first place. I don't care that much. We duplicate this. Okay, no, I'm going to do the proper thing. From if, it's going to take an if info and do that. So here, in the case of an if info, I could do this properly. So this becomes from if info. This becomes from for info. From while info becomes this thing. We have type classes at home. Type classes at home. Okay. Yeah, here for the let info, I don't think there's a point in doing this. So I'm just gonna do that. Okay. And here for the from else, I can use the from if. And in the case of an else block with statements, I guess block, it is a from block. Okay. This is not very elegant because it just extracts a list of expressions in the order in which they appear, which is basically useless for most purposes. Except here, since the point is to compare expressions in definitions that are going to be the same because it's tests that I control, then I can do that to do. For each pair in a zip. Can I write this without having to do it with the zip? No, I think I have to do zip. For zip of the expressions of the reference definition and the expressions of the test definition, which are assumed to be the same, without a plural. This is the singular version. For the zipped version of this that gives me the ref and the test, I will run test equal ref. There we go. Okay. Yes, this is no longer something that makes sense here because it needs to be here. Wait. Yes, this is just only getting one of them, so the concat map makes no sense. Okay. Oh, it is with the location. Okay, so I need to do... This is going to be the located of this. I'm going to actually do the extraction here just because it's going to be a bit more readable. So the reference expressions zipped with the test expressions, assuming that they're in the same order because they're supposed to be the same definitions anyway. And then we get for each of those, maybe instead of doing a for and a zip and I get the pair and I do the thing, maybe instead what I can do is a sequence of a zip with this operator of the ref expressions, of the test expressions actually, and the ref expressions. There we go. I'm going to need having access to representations location. There we go. Unused imports. That is a good error to have because I only have it because warnings are errors, which means everything else is fine in this file, or fine enough at least. And now, hopefully, the test failed. But it means it's compiled and run, which is progress. So... Error, wrong type. Oh, yeah. Yeah, actually, that's a good point. That's a very good point. I have... Oops. And I have broken my layout. That's annoying. I really need to figure out a way to save and restore layouts rather than having to do them manually every time. That's fine. Gonna be good enough for this evening, and I'll redo it for next time. So I have... What I have is a file which is a source file, and I have the simplified file. And what my test does is check that this file after simplification yields the same thing as this. However, there is a problem, which is that this doesn't compile because this returns an int value, and this function is labeled as returning nothing. So here, I'm gonna need to do this. Very quickly. Do this, and this, and it's okay if it's not super precise. I will do this properly for next time. This is the prompt. And this is the progress. There we go. Okay. So now with those files fixed, if we run a test again, okay, this time the test passed, which means that indeed this was simplified into this. And now we can add a bunch of more tests to check more of the simplification phase. If I look at the simplification phase, what do we have? We have addition by 0 and 0, something plus 0 or 0 plus something minus 0 or 0 minus something, multiplication by 1, division by 1, true and, false and, or something like this. But I am very careful here. I am only doing left-hand side short-circuiting. Something, for instance, something and false, the thing on the left-hand side would still need to be evaluated, even if the result is going to be false, because this is not a lazy language, this is more of a Rust-like language, so I can only do this kind of simplification on the left-hand side. This is probably worth testing. So, yeah, I'm going to do a second test file for booleans, I think. Okay, so let's do a few things for those. So if I go back here, let's do this. A function returns an int. Actually, let's do a constant this time. Constant bar, which is an int equals. Actually, let's do it with actually not a constant with a function because I want to test that things get simplified in an interesting manner. So I have here an x, which is an int as an argument. And if I do x plus 0 minus 0, 0 plus, zero minus, so I'll have to be careful, I'm negative now, times 1, one times, to the power of 1. Is there any other I have forgotten? I have forgotten division, but it's already tested by this case here, I suppose. This nonsense should be the same thing as, after simplification, return minus x, because we have the 0 minus here. Okay, something is wrong. Okay. So it is a typed expression on both cases, which is not an L value, that's correct. That has a type int, that's correct as well. It's an int negation expression, okay. Ah, but one of them is an L value and the other is not. Ooh, that is the problem with using equality for. It is the problem of using equality for expressions, is that in this case, minus x is not an L value. Wait. Huh. That's interesting. Because x is a valid L value, but then x plus 0 is not valid. So when I do minus x, I do end up having minus something that is a L value. But that information is lost when it comes time The thing is, I don't care at this stage. The L value-ness has already been checked. I'm torn between, do I fix just this test or just do I remove the equality constraint altogether? And I think I'm going to remove the equality constraint altogether because it is wrong in this case. I'm doing equality constraint and I end up having with something which is irrelevant. Post simplification, I know that this thing is an L value. Now, that being said, could there be reasons to care about the fact that something is an L value after simplification? In other words, is this test correct to fail? And is this simplification thing too naive by not properly analyzing the L value-ness of the result? Because the problem is this. Here I'm saying, when I'm simplifying some kind of typed expression, I am saying that its L value-ness remains whatever it was, regardless of what kind of simplification happens. Why am I doing a simplification on the type? I suppose I could conceive of simplification happening on the type as well. So maybe what I need to do instead, and I need to actually fix that, maybe actually, no, I'm going to consider that the test is correct and found a bug. I think that's the best way to go about this. Here, what I'm going to do is instead of doing this simplification of a typed expression that delegates to this thing and forwards the L value unchanged, what I'm going to do instead is introduce a local function there. Aha, but that's the problem. I am using a rewrite on expressions themselves, and I think that's not correct. I think I need to do this rewrite on the typed expression. Okay, so let's go back to the AST. That means my plated instance. I think I want to have one on typed expression as well. Which is going to be somewhat similar. Except, let me think about this for a second. Is this where the rewrite actually... Hmm. Okay, what I'm doing here is plated is a type class from lens which works with things that have self-recursive. Typed expressions contain typed expressions contain expressions, and so on, which allows for rewrite, which recursively applies transformation function and transform a whole tree of things that are self-similar. Here, what I'm wondering is, okay, what I actually want is a plated instance on typed expression, and therefore I am transforming plated typed expressions recursively. What I don't know, however, is this the place where I perform because here that would be basically the naive instance of doing this would be something like this. I have a typed expression, which I'm going to deconstruct here. What time is it? Okay, not too late yet. Where are you, typed expression? There you are. So the output of this must be a new typed expression in which I have applied the function f on all things within that expression in the first place. However, let me check something about the way plated. It's not going to be here. Yes, so here the naive version of this would be I apply recursively within the type expression the transformation on the typed expressions. And then I rewrap the result that means that I cannot change the L value-ness of the typed expression within the plate instance. However, then I can do a rewrite. Yes, okay, I think this is the correct approach. Okay. So here I am going to copy this here, because the result of this will be a typed expression in which the two first values are the same, for now at least, meaning they are going to be it's going to be the same thing, except the expression value is going to changed. Going to be changed. Expression type, and all of this will be applied within the context of a case of the actual expression. And here the expression will be exactly that. Except within is not required, and yeah, except within is not required. I think that's what it is. Oops. Yep, that should be fine. I can remove some parentheses that no longer need to exist. This one. Okay. That should be fine, I think. If that's the case, then the simplification stage, rather than doing a simplification on the typed expression, on the expression, should instead do a rewrite on the typed expression itself. And given some typed expression like so, the result will be based on the expression value within that typed expression. And here I can keep all of this, but rather than returning the expression value, I am returning the entire typed expression, meaning I am keeping all of the other information as part of the typed expression correct, while having to rewrite, so the L value-ness will be preserved correctly. So now I can just remove all of the exp value thing from this. And I can do just LHS like this. And like this. Okay. That's a lot of changes. Let's see if this works. Ah, the plated instance compiled on the first try. I'll take it. Did the simplification phase. It hasn't compiled yet. Okay. It does not compile yet. Aha, yes, of course. In a few cases like here, the typed expression remains the same, but the underlying expression changes. So here, can I use, if I go back to my AST, I have this L value expression. Yeah, okay. Here, this is always an R value expression. Do I want to enforce whether that thing is... Or in this case, do I want to just forward whatever it was? I guess in this case, I can just forward whatever it was. So here, I'm just going to name it. This is the reference. And in this case here, I am doing a rewrite. Is that correct? If I have a typed expression, which I'm going to create as being an R value expression, of type int type and of value int literal expression 1. If I do x dot exp value is set to be int literal expression 2, so that's not correct. Okay. Because if I do x and exp value, I do get that. That's the correct thing. What am I doing wrong there? Control lens setter. Oh, yes, of course. Yes, of course. This is wrong. What I meant to do is x and exp value is set to int literal expression 2. And okay, except this is not the right operator, it is this one. That's what I wanted. Okay. Okay, so here that would be just ref on which I apply exp value is this. Okay. So here, likewise, it is just the reference that I modify by doing the value is this new thing, but I'm keeping the type and everything else the same. I am doing the same thing here. This is the reference in which I am modifying the expression value to be this. Here, those dollars are not required. Here's likewise. This is, I am modifying the reference by doing exp value is this. And that's the same here, same thing here again. Okay, and here nothing needs to change. Okay, that should be fine now. Minus typos, of course. Okay, simplification compiled. So now we're back to the tests. And now this worked. Okay, so this did indeed find a bug in the simplification thing, where we were rewriting things without preserving the the L value-ness of the underlying thing, which is probably fine because unless the optimization phase actually does some complicated rewrites, but it will do it in the context of knowing how things work, it's unlikely to be needed, but this is more correct. So the tests found an issue, which we like. So again, this x plus 0 minus 0, 0 plus other thing, 0 minus, and so on, all of this gets simplified to minus x. So simplification occurs at compile time, and we'll rewrite this thing into this thing. Okay, so that's a basic thing done. Let's do another one. Let's do boolean.source and boolean.simplified. So what I want to check here is that if I return true and x, okay, I'm gonna try it. Yeah, I'm gonna try all 4 cases for this. False and x. X and true. And x and false. The thing is, those will not all simplify in the same way because of the nature of short-circuiting. So true and x, the left-hand side can be removed. This will be only true, so this should be the same thing as x. This should be false. And those two should be unchanged because x needs to be evaluated, we cannot short circuit based on the right-hand side. However, I guess x and true could be simplified to just be x. But we don't do that. Because here, even if this thing will be false and I know it at compile time, x still needs to be evaluated, because if x is a function call, that function call still needs to be performed. I guess I could try to simplify that. If it's a constant known at compile time, it could be maybe if it's a variable, it can be simplified in the sense of like, yeah, no, that variable, there's no laziness in this language, therefore by that point it will be known and I can short circuit the whole thing to false. But function calls here cannot be removed is the thing. So for now, this is correct. However, let's think about it for a second. If I have a Boolean AND expression, yeah, I guess I would need to check before simplifying it on the left-hand side and right-hand side like this, I would need to check whether any of it can perform side effects, basically. And if the answer is no, if the value can be known at compile time, I can make that simplification without it being an issue. Something else I could think about is doing some annotations. I don't have a lot of annotations at that point in the code, but perhaps for optimization purposes, I could realize this function needs to be called because, like, again, it might perform side effects. However, I know that the result will always be false, and therefore I should be able to make a lot of simplifications moving forward. But it's easier if, as part of the simplification phase, I replace things that I know will always return false or true without performing side effects. So maybe, in fact, I should be matching on things that I know. But the problem is here, I need to basically annotate the thing for can perform side effects, basically. And what that means is if I have a Boolean expression where the left-hand side cannot perform side effects, then I can perform the simplification. And I cannot perform the simplification if one of the sides can perform side effects. Because then it cannot be removed, that would be incorrect. And what can perform side effects? I think anything that contains a function call. Nothing else can. Which would be any kind of call expression. That's the only thing. So maybe what that means is I want to change my typed expression to not only carry this L-value-ness information that is used to check assignments, maybe I want to also keep track of does this perform side effects, or can it be simplified at compile time because it does not? This is a bigger project than what I had in mind for this evening. It's getting a bit late, but I don't think it's too ambitious. Maybe what I'm going to do is I'm going to commit what I have, and then I'm going to do it. Wait, there's no... Why is there... What's the difference there? Binary files differ. What's the option to force a text rendering? Okay. This is so weird. Those are not binary files. They're not supposed to be binary files. Oh, it's the HIE file, not the HS file. That's why. Okay. That's why this should not be part of the... Yeah, I'm just going to remove it entirely. So what have I changed? Undecidable instances in names, which can go away now. I have changed the AST file to add equality comparison on expressions and the new plated typed expression. Okay. I have changed typed expression to now simplification to now be on typed expressions. I have rewritten this thing, and I suppose I'm going to remove the Boolean tests for now. Okay, so I'm going to commit this, and then I'm going to make the change for side effect tracking. So this is what... It's been too long. What convention have I been using for my commits for now? Or lowercase. Add simplification tests with new plated instance. Okay, and that being done, I'll start making a much more complicated change for the purpose of testing the Boolean things. I am going to change typed expression, which is the type I'm using to carry information about an expression after it has been resolved and type checked. So it contains the resolved type, the resolved expression, and some additional annotations, such as, is this thing an L value that makes sense in the context of an assignment? What I'm going to want to add is this thing pure in the sense of, can it or not perform side effects? Something that is it... Can something that performs side effects be an L value? Or is that just separate enough? Because here I have patterns. I have L value expression, R value expression, which allow me to create things immediately without having to specify which of those two Boolean values it is, because I don't like to give Boolean arguments to a thing. Can I create more specific patterns? Okay. If I go back to my analysis file, when do I create something which is an L value? Doesn't seem to happen that often. It only happens in context. Yes, something that is a function argument or a let variable, those things are valid L value expressions. Nothing else is. And if I check here at a call site, I always say that this is an R value expression. And then as soon as something becomes an R value expression, I don't think it can recover L value ness. Yep. The field access expression is only assignable if its core thing is assignable. Okay. So I think that solves my problem, which is that any L value will be pure. Anything that is an L value expression will be pure. Because to be an L value, by definition, it has to be something which is not a function call. It is something that is just a name of something in scope, which referencing something in scope does not perform a side effect. That value is already. So I think in the context of L value expression, I can say that this is always pure. And here the thing is, for an R value, some of them will be impure. Do I want to distinguish between pure R value expression and impure? I feel like a lot of them which will just inherit whatever comes from before. Which means I might want to instead. Yeah, here maybe. I don't like doing this, but it might be. Let me do a quick git grep of this. Yeah, the problem is I can't decide based on the call site. It will depend on the underlying expression. So I think, yeah, I have to do this. which means I might be tempted, rather than using a Boolean, I might be tempted to introduce instead which will be a lot more readable than true, false. Here, this will always be pure. I don't need to change my L value expression call sites. Here, I will need to forward the purity. So now all of these things will have to change. This is going to take a long time to fix. Okay. Let's try to compile this. And let's see where it breaks. It breaks here immediately. That's fine. Now this should break inside the analysis phase. Every time we analyze an expression and we create something which is an R value, our constructor will expect another argument that will be missing. An int expression is always pure. All of those things are pure. Most of them will always be. That's fine. Will I need to put... No, it's fine. Okay. Okay, so here, this is an expression value. Okay. Okay, so this is pointing to a function call. A function call is, by definition, impure. This is pointing to a function definition that is, by definition, impure. This is pure because it is an enum value. Okay, that's all for context. Now, here is where I have binary int expressions. Okay. So here I am analyzing a... Okay. Aha, this int expression thing. This int expression thing, which I think is defined in this file. Which is a template, which is a pattern. Is it defined here? Where is it defined? Pattern in built-in. Oh, it already has the pure. Perfect. Okay, so that's fine. So this is in the context of a constant. So in the context of a constant, it doesn't really matter. Function calls cannot exist, and the purity will be preserved by the call of int expression. So here it's just that I need to discard the constructor explicitly. Okay. It's going to be the same thing here. The purity is irrelevant because I am in the context of a constant where nothing can be impure. Because a constant, by definition, must be computable at compile time. Okay, so here this is also in the context of a constant. I can just pattern match here without any problem. This, however, no, it is still in the constant. Okay. Here, by definition, the struct must be known because otherwise at compile time, I would not be able to compute the value, which means the purity is there again, completely irrelevant. I don't have a proper error for now, it's just an undefined, but having a call expression will be an error anyway here, so all of this is fine. Our value expression, we are in the context of a constant, which means that thing is pure because by definition, I'm in the constant. Not all of it has to be pure. So in the case of a constant, I don't really care. Everything can be labeled as pure. Because I can extremely aggressively simplify constants because I know the values are all known at compile time. Yeah, okay, that's fine. Okay, for a field access expression. Okay, we are no longer in a constant. This is the case of a function. So this will depend so here the purity is important. If the thing on the left-hand side of a field access expression is pure, then accessing a field within it is pure does not perform side effects. So if I end up here, if I end up creating a new typed expression because I cannot resolve it at compile time, then the purity will be the purity of whatever is within. A call expression, regardless of what function is being called, is something that I cannot remove. I guess I could try to figure out whether a function is entirely pure and then label a function call as pure if it doesn't perform side effects. I could do that actually. If a function does not perform, then it can be labeled as pure, and therefore a function call to a pure function is itself a pure function. Let's not do it now. Let's add a to-do for now. For now, this is impure. That, however, will be very annoying to do because that means I will need to annotate definitions for purity, and I don't have that at the moment. Which will be its own can of worms. Okay. For now, I'm going to say I cannot simplify function calls because the function could very well be impure for all I know. Okay, string literal expression, that's going to be pure. I just haven't implemented strings yet. What is this? This is in the context of a constant. And this is for an error case, so really it doesn't matter. This here is also required. Okay. This is a reference expression. By definition, a reference expression is something that points to a path. So by definition, this cannot be, but I already have, yeah, I suppose here, I could make assumptions, but there's no point in making them. I can just get the purity here and pass the purity here. Likewise here, if I have some kind of Boolean expression, its purity matches whether the inner thing is pure or not. Purity here. Purity here. Do I want to create... Yeah, I can make them a semi-group, I suppose. Actually, is there a semi-group instance for Boolean? There isn't. Here, I'm gonna make them a semi-group, which means basically there is a way to combine two purity information into a new purity information, and that gives me access to a bunch of things. And if I try to combine impure with anything, the result is impure. If I try to combine anything with impure, the result is impure. I guess I can do it as like, no, pure and pure is pure. And anything else is impure. Impure corrupts immediately. And I can even make it a monoid. And MMT will be pure. If I have a list of constraints and the list is empty, that thing is pure. But if any of them is impure, then and mconcat will give me impure. Okay. So I can go back to here. So the purity here will be the expression purity of the left-hand side combined with the expression purity of the right-hand side. Okay, a bunch of other functions here. Yeah, at the moment I don't have an annotation thing for definitions, so I am not able to look at a function and say, is that function pure? As in, are all of the statements within it pure? I only have that thing for expressions. I would need to add another layer of annotation for statements and then for definitions to be able to say, okay, what information have I gathered about this whole thing to be able to know by looking at the function, is this whole thing pure? And therefore, can a call to it be removed without risking to impact something, basically. It's actually more complex than that. It's actually more complex than that. Okay, I can't do it with functions at the moment because anything that modifies Hmm. I'm trying to think about references. Because obviously, if I call a function with something that is a reference and there's an assignment within it, that function is not pure. I cannot remove a call to that function because it would modify the context of the caller. So my notion of purity needs to include that if I want to be able to remove it. However, that means function calls are, of course, like an impure function cannot be removed from, it cannot be simplified. But I need to be careful with references as well. Because creating a reference, I have labeled that as being a pure operation that does not modify the context. It depends on what I do with that reference. If it's an argument to a function, then trivially, no, that's impure, we're good. But I think, well, assignment returns something that is void anyway, so I don't think it would be eligible. I think assignment by definition will need to be impure as well. But that suddenly becomes something that is nonsensical for this notion of purity at a function level. Because a function that only assigns to local things is not itself impure, and a call to it can be removed. So the notion of purity within an expression is not the same as the notion of purity for a function. So maybe what I'm doing here is good enough for expressions, Okay, this thing does not modify the current context, can be removed, can be optimized away if I figure it out without impacting the behavior of the program. However, that does not necessarily mean that I can extend this notion to the notion of a function at the moment. Which I will need to gather the information from my optimizer phase. Because if my optimizer phase detect that I am calling a function which is labeled as pure and I'm not using the result, or I am using it in the context where it can be ignored, the function call can be removed. And I think that's something I want to gather as part of this phase. But again, it means that my notion of purity for the expression and for my notion of purity for a function and for a expression needs to be different. Okay, I think since I haven't planned this ahead of time, for this evening, I'm going to focus on purely the expression and I'm not going to do the function level annotations of purity. So for now, I'm purely going to do expressions. And so an assignment is impure. An enum cast is pure. Well, yes, it's a compile time, so we know the value at compile time, so that's pure. Excuse me. I'm going to copy the thing I have here, which I get the purity out of the left-hand side and right-hand side. And I'm going to use that for the purity here. Same thing here. Okay. Compare expressions. Okay. Here, I'm not creating R values. I don't need to. Okay. This is no longer is dead code. Well, that's code I can just remove. Okay. Am I missing anything? I suppose I could look at what is being assigned before blanketing. Maybe the notion of purity can be extended from expressions to functions. I can check, okay, this thing is purely. No, I cannot. Because as far as a function is concerned, if I'm only assigning to local variables, that's pure. That's not modifying anything from the colors environment. It's not modifying the stack. That's purely modifying local stuff. However, within an expression, I cannot remove something that performs an assignment. That's an expression I cannot remove within the function because doing so would like change the behavior of the function. So purity of an expression and purity of a function are two different things. Maybe what that means is at the moment I have purity for the expressions, and I need to introduce another variable that is being collected, which is, does this impact the purity of the function? I mean, that's what I need to do. But maybe this purity thing can be performed later on rather than being collected the way it is now, because that's part of the optimization phase and not part of this phase. That just means retraversing a bunch of things, which feels very unnecessary. Okay, so here, this is, oh, cast. The purity of a cast will purely be based on the purity of the underlying expression. If I'm casting the result of a function call, that's impure. If I'm casting a literal, that's pure. So this will purely be the express. Well, I'm going to call it here purity. That means here purity is the expression purity of the resolved expression, which I guess I can put here. So purity here, our value expression purity here. Okay, what else am I missing? I've already done those. Here, that's because that's a, I haven't done string handling yet. What am I missing? Okay, let's see. And that's an assignment expression. For now, assignment expressions, regardless of what they are impure. Which is correct from a... that being said, since function expression simplification will not probably happen on assignment... Result cast, this will be the purity. I have a purity in scope, I think. I don't. Oh, did I do the mistake of... Did I make the mistake of cast... It's not a mistake, but... Yeah, okay, this purity thing is within the context of a constant. That's kind of useless because constants will, by definition, always be entirely pure because their values need to be known at compile time. So... Actually... Yes, I don't mark constants as L values. That would be a mistake. Okay. Here I have the purity anyway. Perfect. Okay, so this is a bunch of casts, and I guess I can do purity there. And I'm realizing that it's going to open the possibility for a lot more optimizations and a lot more simplifications, which is good. For instance, multiplication by 0 is something that I could not say, oh, the result of multiplying something by 0 is 0, because maybe this was a function call that needs to be performed and cannot be removed, and like might perform side effects that need to happen, and I cannot remove a function call. However, if I can detect that the other thing is pure and therefore will not perform side effects, I can remove it entirely and replace the entire thing by 0. I suppose, however, I do detect division by 0. The simplification phase happens after I do the checks for division by 0, which means if I divide by 0 times something that is pure, that simplification phase will replace that by divide by 0 after the check for division by 0, and I will not emit a diagnosis there, which means it will fail at runtime, which I think is okay. Okay. So here, that's a struct expression. Here, this is interesting. The purity of a struct expression will be the concatenation of the purity of the fields. If all the fields are pure and obtained without side effect, that thing is pure. However, if any of the fields is obtained by calling a function or performing something that contains side effects, then that expression is no longer pure. So purity I mean, Homestuck does contain a lot of programming references. It contains, at the very least, two fictional programming languages. It's not what got me into programming. I was already studying programming when Homestuck started to release, but I wouldn't be surprised if, for some people, a very small number of people, that actually was the inciting incident. So here I have the resolved fields, which are the typed expression of each individual field for this struct expression. So that means I need to do a, not concat map, that's the wrong thing. I think fold map is what I want. Google to the rescue. Where is fold map? Maps to something that is a monoid. Yeah, that's what I want. So I want to fold map expression purity of the raw resolved fields. This will map to each field its purity and then combine that list into one thing. If there is no field, it will be pure. If all the fields are pure, this will be pure. Otherwise, it will be impure, which means here I can just give the purity as an argument to the R value expression. Perfect. For now, for references, taking the reference of something is a pure operation. Assigning it would be impure. I think that should be basically about it. What am I forgetting? Here, for the compound assignment, this is always impure, so I can ignore the purity information. Assigning something will always be an impure thing at the expression level. Here, this is not just the fields, it is a tuple key value of the name of the field and the typed expression. So here I need to take the second value of the tuple and then get the purity. I remember doing the simplification phase in one evening as like, oh, we can move that separately, right? And now I'm running into a bunch of issues with it, which is interesting. Okay, so this is the simplification phase. Perfect. So now this is the part where we go back to simplification and we can change things quite a lot. Because here, something plus 0, it doesn't matter if the left-hand side is pure, the result will be, I can simplify to just the left-hand side. Likewise, for 0 plus, I can just simplify to the right-hand side. So here, for subtraction, likewise, I can replace by something, like this is just an int negation, and so on. However, this is where I can do things that are a tiny bit smarter. If I am multiplying something by 0 and I want to introduce a new function. Is pure is pure is simply conversion to Boolean, basically. I could almost do that as a cast if I were to change the order here. And if I'm multiplying something by 0 and the thing on the left-hand side is pure, actually, I'm gonna not do that on purity itself. I'm gonna do it on typed expression. This here, and I'm gonna move this here. There we go. Is pure will be a case of a typed expression. This will be get the expression purity and then do a case, and if it's pure, say true, and if it's impure, say false. And now I can say, if I'm multiplying a left-hand side by 0 and that left-hand side is pure, then this becomes just an int expression 0. Because I know that the thing on the left-hand side cannot perform set effects, cannot panic, cannot do anything, and therefore is safe to optimize away. And if I have the same thing, I'm multiplying 0 with something, and that right-hand side is pure, then that becomes 0. Division by 1, already done. Division by 0, already handled at compilation time. If this creates a division by 0, it will not be caught at compilation time. I think that's fine. I guess, well, the problem is if I were to like catch division by 0 here, this phase at the moment does not return diagnostics. It's purely a pure transformation. I would need to plated. Where are you, plated? I'm doing a rewrite. Well, that's not what I wanted. I wanted the documentation, not the source. There we go. I am doing a rewrite. Can I do a rewrite that returns something within? Yes, rewrite M. Okay. So I could do something that does the rewrite within some kind of context, and I could add error handling to my rewrite so that I could handle the fact that a rewrite could create a division by 0. So I will need to introduce diagnostics into this phase. Okay. And here, likewise, I can always say that something to the power of 0 is 1 if that thing can be safely removed. So if it is pure, then that is an int expression 1. Oh, oops. 0. Here I am doing this kind of short-circuiting of the Boolean AND and the Boolean OR. I can do the short-circuiting the other way around if the thing is pure. So that means if I'm doing something on the left-hand side and true, it's the same thing as just doing the thing on the left-hand side, because if it's true, the result will be true. If it's false, the result will be false. The and true doesn't matter. And if I'm doing something and false, I know the result will be false, but it can only be simplified if the left-hand side is pure. So there's a few more annotations I'm realizing I will need. I will need some way of tracking function purity, so that I can extend this purity thing to can I remove this function call without impacting the behavior of the program? I might want to also extend this to keep track of I know this thing will be false. I know ahead of time the value of the result. However, I cannot change the expression to simplify it. For instance, in this case, if the left-hand side is impure, it's a function call, I cannot remove it. I cannot change this. I need to keep it in place because it could perform side effects. However, I know that the result of this value will be false, and therefore I should probably keep some kind of annotation there so that I can do a rewrite later on that makes use of that fact. For instance, if I assign this to a Boolean let afterwards, it would be very useful to know that this value will be assigned false, and therefore that for all of the following if statements, it will be false. So it would be useful to keep track of known values at compile time like this so that I can do optimizations. But that's a lot of work for later. Optimizations will probably not be part of the first phase. But here I can, at the very least, okay, you're doing A and false. If A doesn't perform side effects, it doesn't matter. I know for a fact that the result of this will be a Boolean expression false. Okay, that's better. That's more stuff. I can extend the Boolean OR the same way. I'm just going to align this for readability. There's no right-hand side here. This is purely, there we go. So here for a Boolean OR, if I'm doing something OR true, if that left-hand side is pure and can be removed without changing anything, then that is just a Boolean expression true. However, and in the case where it's something and false, I can always replace with just the left-hand side that and false does nothing. Okay. Okay, Boolean negation of Boolean negation, that's always true. Int negation of int negation, that's always true. Except, I suppose, for out of bounds, but we don't. This is when I have, yeah. We're just gonna ignore that problem. Um, yeah, equals true equals false. We can simplify. That hasn't changed. Okay. So now I can go back to this is no longer correct because I was saying true and x will short circuit to just being x, false and x will simplify to just being false. But when the constant is on the right hand side, no simplification will happen. That is no longer true. Now that we have purity analysis, we will simplify this. So I'm expecting this new test to fail on both B3 and B4. When this compiles, of course. And then I'll stop because it is getting late. What is recompiling the AST? What have I changed in the AST? Oh yeah, of course I've added the purity thing, of course. Aha. Ah, yes. Um yeah, I suppose I can ignore the purity of a Boolean negation expression if I'm gonna replace it with whatever is within that purity information will not be important. So I can just pattern match anything. Okay. So now this compiles, so we're moving on to compiling the tests, and I expect the test to fail. Yep, there we go. That's because I have written them completely wrong. Fun is not a keyword. It is the same as in Rust. It is N. Let's rerun the tests. I still expect them to fail. Okay. So here I got a typed expression. I'm expecting something that is a Boolean AND expression. Oh wait, do I have it the wrong way around? This would be in simplification here. The test value is the result. The reference is I'm passing the simplified version. Test value is I'm passing the source. So the test definitions are the test value, the reference definition are the reference. Interesting. Okay, so let's see what the error is here. So here on the, I am expecting a Boolean AND expression where I have x and x and true, and instead I got x. Yes, of course, that is correct. The test is correct to be wrong, because what it is saying is, after simplifying this, I got that this was just x, which it is true. And here I'm saying the reference is saying, no, it should be x and true, which is wrong. So I need to fix this. And now I'm still expecting it to be wrong for the last test. There we go. Because here it's saying that it's still a Boolean and expression, while here what I got was actually a simplification into false. Because here I know that this thing cannot perform that effect. Evaluating x cannot perform that effect. The function call will still be the same. And therefore, I have evaluated that x that does not perform that effect and false will be false. So now I have fixed my reference. My test should be correct. There we go. So this evening, I started with, we should just start adding tests for the simplification phase, and we ended up rewriting the simplification phase to keep track of purity and doing a bunch of fun things like this. On Thursday, I'll probably continue with this notion of like, can we annotate things during the simplification phase? Can we keep track of function purity, that kind of things? I think that would be interesting to try to do more annotations. That also means probably changing a few more things, doing more simplification tests, adding diagnostics as part of the simplification phase. That's gonna be a lot of work, but I think we can continue with that. And I still want at some point to go over the documentation that I have at the moment, which is very, very basic, but to start expanding either with a system of notes within the code or either with like external documentation on some of those concepts. What does it mean for a expression to be pure? I don't want to have to discover it based on what the code says in 6 months. I want to have documentation that explicitly states it, and I want to have more tests. So yeah, I'm going to stop here for the evening, and I will see you all on Thursday.